Name of the experiment is COD of industrial wastewater. Aim of the experiment is determination of COD of industrial wastewater using standard FAS solution, ferrous ammonium sulphate solution. In this experiment, COD means it is the amount of oxygen required to oxidize both organic and inorganic waste present in the industrial wastewater using standard K2Cr2O7 solution. And by doing this experiment, we will come to know to what extent the industrial wastewater is polluted, and before leaving any such industrial wastewater into any water body, we should check the level of COD. If it is very high, we cannot leave such wastewater into the water body. So that by doing some chemical techniques, we have to reduce the COD level, then such wastewater, industrial wastewater is fed into the any water body. Reagents required for this experiment are ferrous ammonium sulphate salt water sample, waste water sample, potassium dichromate solution, 1:1 sulfuric acid, dilute sulfuric acid, and the indicator is ferroin indicator. And the apparatus required for this experiment are 50 ml burette with burette stand, volumetric flask 250 ml, conical flask 250 ml, and then funnel, then one test tube with holder, weighing bottle, spatula, and then we have to use 2 pipettes 250 ml capacity. One pipette is used to pipette out waste water sample, and the other pipette is used separately to pipette out potassium dichromate solution. Before starting any experiment, we should wash all the apparatus well with water. First, I will show you how to wash the burette. Collect the water in the water bottle, transfer water into the burette, rinse the whole burette and wash it well with water. Then clamp this to the burette stand. Take the volumetric flask, wash well with water. While washing, you should be very careful because all are glass apparatus. Wash the conical flask well with water and wash the pipette. To wash the pipette, we have to collect the water in the conical flask and then we have to pipette out with the help of pipette. This is 25 ml pipette. Pipette out the water. Rinse the whole pipette. And wash. Wash the funnel also well with water. And then in this experiment, first we have to prepare standard ferrous ammonium sulphate solution. Standard solution means whose concentration is known, and we can calculate here the concentration of the solution. For that, first we have to transfer ferrous ammonium sulphate salt into the weighing bottle, and then we have to weigh this weighing bottle and the salt, that is W1, and then we have to note down the weight, then transfer it into the funnel which is placed over the standard flask. Then we have to weigh this empty weighing bottle, that is W2. If you take the difference between W1 and W2, we get the weight of salt which is transferred into the funnel which is placed over the standard flask. And now we have to add half test tube of dilute sulfuric acid into this one. Dilute sulfuric acid is added to avoid the hydrolysis of ferrous sulphate. Now With less amount of water, we have to wash all the crystals down into the flask like this with minimum amount of water, and after washing like this, then we have to remove the funnel. Then we have to hold the flask like this and mix well until you get clear solution. When once you get clear solution, then we have to add now the solution. There is no salt down. Then we have to add what we have to transfer water from the water bottle up to the neck of the standard flask. Only up to the neck we can transfer from the water bottle. Then to fill the remaining portion of this volumetric flask, we have to add water up to this mark. If you add water up to this mark, then it is 250 ml standard solution. To fill this portion, we have to use the burette. First we have to fill the burette, tight this knob and then fill the burette with water. Now we have to lift this little bit up and then place the standard flask, and then we have to transfer drop by drop. See, since the solution what we are taking here is colorless, we have to adjust the lower meniscus of this solution exactly to this mark. When the solution comes to the mark, we have to stop the burette. We have to consider here the lower meniscus. If the solution is colored one, then we have to consider the upper meniscus. Why? Because if the solution is colored one, we cannot see the lower meniscus properly. So therefore we have to consider the upper meniscus for colored solutions, and if the solution is colorless, we have to consider the lower meniscus, since we can see clearly the lower meniscus. To stop it, now the level is, the lower meniscus of this solution is exactly on the mark now, and now fix the lid. Then we have to invert the flask like this, and we have to mix well for uniform concentration 4 to 5 times. So if you forget to mix the solution, then you will get different concentration. Usually at the bottom level different concentration and top level is different concentration. So we have to mix the solution well. This is very, very important. After mixing the solution, then we have to remove the lid. So before adding water up to the mark, we should not fix the lid at all. This is very important. And suppose while mixing, if you lose the solution, then you should not add the water. Then keep the standard solution little bit inside and then remove the water which is there in the burette. Now we have to take this prepared standard ferrous ammonium sulphate solution into this burette. Place the funnel over this burette, and we have to hold the funnel like this by leaving some gap, otherwise the solution will overflow. See, we have to take less amount of ferrous ammonium sulphate into this one burette, and then remove the funnel and then rinse the whole burette with the prepared standard ferrous ammonium sulphate. This rinsing is done to avoid the dilution of ferrous ammonium sulphate solution. We have to maintain the same concentration what we have prepared here. So we are rinsing the burette, and after rinsing the burette, we have to throw the rinsed solution into the sink, then tight this knob and then place the funnel over this burette, then hold it like this with small gap here, and then transfer the prepared standard solution into the burette. Or even we can transfer by holding like this very close to the burette. Now we have to adjust the level to 0 by removing some solution through this nozzle. Since the solution what we are filling in the burette is colorless solution, here also we have to adjust the lower meniscus exactly to 0 mark. Fix this to the stand and we have to ensure there should not be any air gaps below this nozzle portion. Then we have to take one clean conical flask. Into this clean conical flask we have to transfer exactly 25 ml of waste water sample with the help of 25 ml pipette. Before using this pipette, first we have to rinse the pipette with this solution, so that we have to pipette out small amount of the waste water sample. Then rinse the pipette with waste water sample. Then throw the rinsed solution into the sink. Hold the stock bottle like this. Suck the solution above the mark and then with the help of your forefinger adjust the level to the mark. Here also we have to consider the lower meniscus. Then now we have to transfer exactly 25 ml into 250 ml conical flask. After this we have to slant the conical flask and then tap the tip of the pipette to the empty base 2 or 3 times like this and then remove it. Then we have to transfer again with the help of another pipette, we have to transfer again 25 ml of potassium dichromate solution. Before transferring the potassium dichromate solution into the conical flask, we have to rinse again the pipette with potassium dichromate solution. While sucking the solution, the tip of the pipette must touch to the base of the stock bottle. With less amount of potassium dichromate, rinse the whole burette and then remove the rinsed solution, throw it into the sink and then pipette out exactly 25 ml. Suck the solution above the mark. See, we can see the mark here. What the solution we are taking in the pipette is colored one, and here we have to adjust the upper meniscus to this mark. We have to use always this forefinger to hold this pipette. Turn the pipette very slowly and then adjust the upper meniscus to the mark. When the solution comes to the upper mark, upper meniscus, then transfer it into the conical flask. Now again slant the conical flask, tap the tip of the pipette to the empty base 2 or 3 times. Then we have to add 1:1 sulfuric acid, 1 test tube. Now we have to add the ferroin indicator 3 drops. Now mix the solution well until you get blue-green color. See, now the solution is green in color. This green color solution, it is titrated against prepared standard ferrous ammonium sulfate by adding drop wise. Before starting the experiment, first we should ensure whether the level is there at 0 or not, and then if it is there at 0, then hold the burette with your left hand, hold the knob of the burette with the left hand and hold the conical flask neck with the help of your right hand, and by adding drop wise we have to mix the solution. The standard solution is added in drop wise. Solution is added in drop wise with constant mixing until the color green color changes to reddish brown. We should keep observing the color change. We have to add the solution slowly. After every addition, we have to mix the solution, and when we get color change, we have to stop. We must be in a position to stop the burette to which particular drop we get color change. See, now it is very near. After every addition of one drop, we have to mix the solution and we have to check the color. See. See, now this is the end point of the titration. Now we have to remove the burette from this stand and we have to keep it exactly to your eye level and we have to note down the reading. Now the reading is 21.3. So here also we have to consider the lower meniscus of the solution. Note down this reading, and then again for the next trial we have to wash the conical flask again well with water and refill the burette up to 0 again. In the same way, again we have to do 2 more trials, and those readings are entered in the tabular column, and out of 3 readings we have to consider any one reading, that is V1 value. By using this we can calculate the COD, and this type of titration is called as sample titration, or it is also called as back titration. And one more titration we have to do, that is blank titration. Blank titration means except wastewater everything is same, and in the same way the titration is continued, but here we need not to do any blank titration. Whatever reading we get for the sample titration or back titration, we have to add 10 for this one and we have to consider. Example, this reading, this is the back titration reading, it is 21.3, and for the blank titration we have to add 10 for this one. That means it will become 31.3. 31.3 is the blank and 21.3 is the back titration. If you take the difference between back and blank, that is V2 minus V1, then we get the amount of dichromate used for the oxidation of waste material present in the wastewater. After the experiment is over, we have to enter the readings in the tabular column. See, here we have written 3 readings. Out of these 3 readings, we have to consider any one value. So this value is considered as V2, and this is the back titration value. And then we have to write the blank titration value by adding 10 to this one. If you add 10 to 17.5, we get 27.5. And then we have to calculate the COD of the industrial wastewater. To calculate the COD of industrial wastewater, we have to take the difference between V2 and V1. That is, here the difference between V2 and V1 is nothing but it is the difference between back and blank titer value, and then we have to substitute the normality of mode salt. This normality of mode salt we can calculate by using this equation, that is weight into 4 divided by equivalent weight of FAS. Using this equation we can calculate the normality of mode salt, and this normality is substituted here for Nm, and then it is multiplied by 8000, then it is divided by 25. Finally we get the value in terms of milligram per liter. The same value can be expressed even in terms of ppm, and here the final unit is parts of oxygen per million part of wastewater, or milligrams of oxygen per decimeter cube of wastewater. The final answer, it is written in this result value. See, this is the sample record. In this record, we have to write the observation calculation part in the left side, and in the right side we have to write the aim principle, procedure, and finally the result. Procedure and finally the result. So usually the students will do the mistake while preparing the standard solution. So they have to add exactly the water by considering either lower or upper meniscus. Suppose if the level goes up, we cannot use such solution. Again we have to repeat the preparation of standard solution, and also before starting the experiment we have to ensure whether the level is there at 0 or not, and also we have to hold the burette with your left hand and the conical flask with your right hand, and the same fashion we have to follow throughout the experiment. The probable viva questions in this experiment are, they'll ask you the definition of COD, then what is the unit of COD, why 1:1 sulfuric acid is added, and then when you do blank and back titer value, why we get higher titer value for the blank and why less titer value for the back titration. So these are some of the possible questions.